We have a voltage source of what, 36 volts? If I'm seeing it right there. And we have element 1 here. I didn't tell you what's even in it. We have the second element right here. We have the dependent source here, minus plus. And we have the third element. And I know the current, if I'm seeing it right, I label the current going in here. What? 4 amps?
Yeah.
And I label the voltage here plus to minus 12 volts. I have the current, I think, coming down. Is it coming down? 2 amps. I have the current going this direction, 2 amp. And is that one I sub x?
Yeah, that's one I said.
1 I sub x. And I sub x is this one, the 4 amps. And the question, can you calculate the power supplied or absorbed by each one? So let's look at this one, the source. The power by the 36 volt source, this one. We have a current 4 amp going this way. The 4 amp is entering which end?
The minus.
The minus, so it's a negative power. V times I, 4 times 36. That's negative what? 144, is it?
144, yeah.
44 times, 36 times 4 is 144. So this is actually, it's 144 watts supplied. Minus means supplied. Plus means taken, observed. Now the power by the 1 ohm, the element 1, we're not sure if that's even a resistor or what. We know V times I. Notice we enter in the plus, that's a positive. 4 times 12, which is 48 watts. So that would be 48 watts, and that's taken. The power, I forgot to label some of the labels here. This is plus 24 here, plus to minus 24 volts. And plus to minus, I think the last one is what?
28.
28. So let's look at element 2. We have a positive current entering the positive terminal. That's a positive 2 times 24, which is what? 48 watts. Power by the third element, that's this one. Again, positive current entering the plus, that's a positive 2 times 28. Is that 56?
Yeah.
Now if you add the pluses here, they're actually more than 144. 56, 48, and 48 is bigger than 144. So somebody else is supplying power. Let's look at the dependent source. We know the voltage here is what? It's labeled minus to plus. So this voltage is 1 I sub x. It's minus to plus 4 because I sub x is 4. We have a positive current. The 2 amps is going this way. It's entering the negative. So by that dependent source, that power is minus 4. That's the voltage times the current, which is 2. And that's a negative 8 watts. And that's the solution to question 1. That's what I look for when you're making a test. I want to see you label the stuff, so when I look at it, I know exactly what you're thinking instead of just numbers. Some of you try to squeeze everything on that cover sheet, and I had no idea what you were doing there. Doesn't take much. Take a nice sheet of paper, write the stuff on it. It's nice and neat. Let's look at number 2.
I got it right on that one. They subtracted 3 volts from that.
Number 2. Plus minus 2I sub x and this is 4 ohm. We have I sub x entering that direction. That means it's going to mark that resistor plus to minus. We have a voltage source here of 12 volts. And we have 12 ohms, and we label Vx here in this direction. And there's another voltage source here. And the question, what's V out? V out is labeled right here. That means if you attach your meter right here, what is V out? Imagine if I attach my meter here, let me take a pencil and attach it there. Because I'm going to erase it after that. There we go. This is my meter here. I'm going to attach it right here. You know, in the lab, you take the black one, you attach it to the minus, the red one to the plus, right? So this is my meter. What am I reading? Well, if you do that, you have a closed loop right now. And if you travel this way through it, what are you going to have? You'll have negative V out minus 12 minus Vx is equal to 0 if you travel this way. Which means what? V out equals what? Negative 12 minus Vx. That's what V out is. V out is labeled as plus on the left side, minus on the right. So if I know what Vx, I'm done. Well, how do you find Vx? Well, let's look at that picture. We have I sub x going this way. There's only one way for the current to go. This is I sub x. That means Vx is going to be negative 12 times I sub x. Negative. Why? Because I sub x is going to mark it plus to minus. That's different direction. So if I do KVL right here, sum of the voltage in a closed loop is 0. Let's go through that. Negative 2I sub x plus 4I sub x minus 12. This will be plus 12I sub x plus Vx is equal to 0. Actually, I could write minus Vx and the two of them will cancel each other out even. Make my life easy. I can make my life much easier. Instead of having that, which is fine, I could have wrote minus Vx. And what happened to plus Vx minus Vx? Gone. So what do you have? You have 2I sub x equals what? 12? What is I sub x? 6. What's V sub x? Negative 12. Vx is negative 12 times what?
6.
Times 6. Just making sure here. And that's what? Negative 72. What's V out? Well, we said V out is negative 12 minus Vx. Well, what's Vx? Negative 72. What's negative 12 minus a minus? $60 volts. The solution will be posted on the website too. These. This paper is not good. It bleeds through. Oh, the markers bleed through. Let's look at 3. Finding our equivalent. 2K, 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 2, 2, 2 again. Uh-oh. 1, 1, and 1, right? What is our equivalent look in that direction if you were to measure that? Well, I see these 3 are connected how?
Series.
So I can make this circuit look like this. 2K, 2, 2, 2, all the K's are 2's, 2K, 2K, but now I got what here?
3K.
3K. Now these are connected in parallel. It is, bless you, the product over the sum, 2 times 3,
6.
over the sum of them,
5.
so it's 6 over 5K. 1.2 is it?
Yep.
So it will look like this. 2, 2, 2, 2, and we said, what was it, 1.2 here?
Yep.
6 over 5. These 3 are connected in series. We add them. Is that 5.2?
Yep.
And how are these connected?
In parallel.
Product over the sum. 10.4 over 7.2. Where's my calculator?
1.4 repeated.
1.44.
Yep.
Okay. So now I have 2K, 1.44K, 2K. The result is what? 5.44K ohm. Try to freeze it. I forgot you can't freeze it when you're running the camera. So let's look at the next one. Number 4. This is 6K, and we have this one labeled as V1. We have a current going up there, and the value of that 6 milliamp. We have a dependent current source coming down, which is 3 times I sub x, and I sub x happens to be this current. We have 3 milliamp, 2K, and 3K. And the question, what is I sub L? This is I sub L. Well, if you look, all these 1, 2, 3, 4, 5, 6 elements connected how?
Parallel.
They have the same voltage, which is what? V1. So I sub L is equal to V1 divided by 3K. So if I know what V1 is, I'm done. I can find I sub L and I sub X. So now, KCL at the top. All the currents are labeled except here. We'll call this I sub Y. Sum of the current going into that node is equal sum of the current leaving that node. And what is going to that node? I see the 6, is that it? And what's leaving?
3IX.
I sub X plus 3I sub X plus the 3 milliamp plus I sub Y plus I sub L. I can move the 3 to this side, make it what? 3 milliamp equals 4 I sub X plus I sub Y plus I sub L. And let's write each one in terms of V1. I sub X is V1 over 6K. I sub Y, it's V1 over 2K. And I sub L is what? V1 over 3K. What's my LCD? 6K. K and milli will cancel. 18 equals. K and K gone. 6 and that's 1. That's 4 V1. 2 and 6, that's 3 V1. Is that 2 V1? 18 equals 9 V1. V1 equals 2 volts. I sub X, if you need it, it's V1 over 6K, which is 1/3 milliamp. We didn't ask for it. And I sub 1 is V1 over 3K, which is 2 over 3K, which is 2/3 milliamp.
Well, we get 3 points if we got this.
I don't like you.
Fair enough.
That's what I got.
Yeah.
Yeah, but really, like,
Then I crossed it out?
yeah.
I probably was looking for I sub X and I sub L. I probably thought you meant I sub X instead of I sub 1.
Yeah, no,
Or I sub L.
here.
Yeah.
Yeah, yeah, okay. So that's what the question. That's 4. Two more. 5. What do we have? Is that 5? Yes. Find the value Vs. So the source is unknown. Three ohms. Three amps. 8 ohms. Oh, I'm sorry, that's 18, the first one. Vs is on the right side. This is 18 volts. And this is Vs.
You missed the resistor.
I missed the, oh yeah, 2K. Ohms, now there's no K's here, I almost said 2. No K's, everything is ohms. So that's what the circuit is. The question, find Vs if what? If the power supplied by the 3 amp source is equal to 0. Well, power is what? Voltage times current. For that to be 0, for this to be, we know the current is 3. 3 times what will make it a 0? So V will have to be 0. That voltage here has to be 0. So if I assign current I sub 1, if you look at that circuit, if you want to redraw that circuit, you could redraw that circuit, just make this kind of a ground, except there's a current going through it. But I'm going to put some current we called I sub 1 here. And there's current going this way. Notice the reason I'm making it this way, because my source here is negative to positive. I'm thinking it's going to go in that direction. If I'm wrong, so what? The direction will be backward. My source, negative to positive, I think is going to go in this direction. But again, I don't have to worry about, is this the right direction? You know? And if it's not, we'll see. So I'm assuming I sub 1. So if I do KVL in this node, if there's I sub 1 going this way, that means what? There's I sub 1 coming this way. There's no other way to exit. It has to be coming all the way here. From this end to that end, the same current. I sub 2 is going this way. I define it going this way. That means entering this way. So let's do a KVL right here. This area. Minus 18 plus 3 times I sub 1 plus the voltage drop here, which is 0. Notice I'm going this way. That's plus 2 I sub 1 is equal to 0. 18 equals what? 5 I sub 1. What's I sub 1 equal to? 3.6 amp. Let me do KVL for this one. Let me make it going this way. I like to go from the minus to the plus of the source. That's just me. So I'm going this way. And by the way, if you know I sub 1, can you tell me what I sub 2 is?
Yeah.
I sub 2 is going to be going which direction?
Opposite direction.
Opposite. Why? That's a node. If I do KCL at top, when I say top, this point, the current entering the node, which is what? I sub 1 plus 3 plus I sub 2 is equal to 0. I sub 1 is what? 3.6 plus the 3. That tells me what's I sub 2? Negative 6.6. That says my direction with the current is wrong. So let me go back here and reverse the direction. I was wrong. It's gonna, well, now it's gonna make that equation wrong. I'll correct the equation too. So the direction I thought it's gonna go, I was wrong here. So it's gonna go this way. So this now makes this one what? Plus, plus, and makes that a plus. Because I changed the direction of it. And let's do KVL on this one. Let's travel this way. 8 times I sub 2, so KVL again. Start from here. 8 times I sub 2 plus VS plus 6 times I sub 2 plus 0 is equal to 0. VS is equal to what? Negative is a 14. So that's negative 14 times 6.6. What's negative 14? 14 times 6.6. 92.4. 92.4 volts. And the last one. Again, all of these will be posted on the website today. The video and the notes. The last one, question number 6. We have VS. $2K. $6K. $4K. 4K, 1 and 3. And the question, if V1 is right here. If V1 is equal to 12 volts, can you find VS? Well, if Vn is 12, do we know what that current there is? Let's call it I1. Can we find where I sub 1? Isn't I sub 1 V1 divided by 4K? Which is 12 over 4K. Is that 3 milliamp? Okay, if I need it. I don't know if I need it or not, to be honest with you. We'll see. Why not combine these two into one resistor, which is what?
4K.
4K. In parallel with 4K.
2.
That would make it a 2. We know the current going through this is what? We just did that. 3 milliamp, right? If I combine these two, does that change the current?
No.
No. And this is 3 milliamp coming down this way. I can do the math, but the fact these two resistors are equal, guess what that current here is? 3 milliamp. Has to be. because the voltage is the same across them. What's the voltage between top and bottom? V equals 3 milliamp, the current, times the resistor, which is 6K, and that's 18 volts. So you want to find the current here? You go 18 divided by 6 is 3 milliamp. 3 and 3, that's 6. There's a current going this way of what? 6 milliamp. It's going to be a voltage drop here of how big? There's a voltage drop here, plus to minus. 6 times 2 is 12 volts. There's a voltage here, plus to minus of what? 18. So if I do KVL here, we have what? Negative Vs plus 12 volts plus 18 volts is equal to 0. Vs equals what? 30 volts.
How did you get the 6 milliamps again? So,
Sum of the current entering a node equals sum of the
Oh,
current
okay.
leaving. KCL.